Okay, Assalamualaikum and hello. Welcome back from your break. Okay, so today we will start with a new topic. Okay, so power system load. Okay, previously we focused on generation and then transmission and load. Okay, before we proceed, for the test one, we focus on topic 3.1 and 3.2, generation and transmission. So for test 1, make sure you prepare either 10 January 2022 or 17 January 2022 at 9 p.m. Okay, so make sure you clear out your both of your tests. Okay, both of the date for the test. Okay, I will confirm back when is the test. Okay, but mostly just stick to the original date, which is 10 January. Okay, because of the clash, another section has clashed with another test at 17. Okay, so probably 10 January. So it's around 2 more weeks. So prepare chapter 3.1 and chapter 3.2. So now we continue with chapter 3.3, okay, which is power system load. Okay, so basic power system. Okay, so power system load. So this is the outline. Okay, so at the end of this class, you should explain the types of electrical load, define and determine various terms and factors in power plant engineering, explain the nature of load and how they are met, and explain, determine and analyze the tariff and energy consumption and cost customer. So this one is basically your assignment 1. Okay, so let's start with the introduction. In our daily life, we use many forms of energy such as mechanical, heat and light. Electricity is special as it can easily transform from this form of energy. So this chapter discusses characteristics and ways of electric being used and how utility meet this demand economically, effectively and satisfactorily. Okay, so you have two types of load. Okay, wait, I have to check the recording first. Okay, so there are two types of load, either residential load or commercial load. Okay, so if residential basically is just a domestic, like power for domestic appliance like radio, television, water heater, refrigerator and etc. Okay, this is residential load. For commercial load, it is lighting and air conditioner for shopping complex, office, hospital and school. So basically commercialized load is for business, residential is for living. Okay, so there is also industrial load. Okay, so this one is much more higher power. Okay, commercial is much more lower, usually much more lower, but industry is much more demanding. Okay, and mostly for industry you have a 3-phase induction motor. It is the main load for industry, and then you have a public lighting and municipal load. Okay, this one mostly on street lighting. Okay, power, water and drain purpose. Okay, agriculture. Okay, this one for motor. Okay, to pump the water and as well as the light. And then the mining also for using motor. Okay, so this one is the type of load available for this one focus on the TNB. Okay, TNB types. Okay, so connected load. So connected load is on any system or part of the system is combined continuous rating of all receiving apparatus of the customer premise which connected to the system or part of the system under consideration. So this one is the connected load. I think no need to explain too much, just load connected to the system. Okay, this one is demand. Okay, you need to know the term demand. So demand of the installation or system of the load drawn from the source supply receiving at the terminal average over suitable and specific interval of time. So this one is just power needed by the load. Okay, so demand is basically power needed by the load. Okay, it's usually expressed in kilowatt, or sometimes also kVA, or also ampere. So what is the demand is basically what is the load right now. Okay, so maximum and peak demand, another terms is maximum and or peak demand or load. So maximum demand of the installed or system is that the greatest demand that have occurred during the period. So it's determined by the measurement according to the specification over prescribed enough interval time. So basically you need to know what is the max demand. Okay, so this is the demand at that specific time. So and this one is the maximum demand. So let me open the. Okay, so for example, you have a graph here. Okay, demand time. Okay, so you have a demand, something like this. So peak demand is basically this one. Okay, so this is the peak demand. Okay, so we continue. Make sure you know the terms. Okay. Okay, base load is an unvarying load which occurs almost whole day on the power station. It is the lowest load can be supplied at any time. So you can see here from this drawing. Okay, this one is wrong. Make sure there is no reverse. Okay. So, okay, something like that. Okay, so base demand basically the load that occur for the whole day. Okay, if you can see here, this is the lowest one. Okay, so this is basically the base load. Okay, so the lowest one, so it occur all day. Okay, whole time. So you can see here it will never go down like that. So basically this is the base load. Okay, intermediate load between the base and the peak load that have to be fed by the system. So this one, from this one to this one is intermediate load. Okay, this one is peak load, intermediate load is between them. So basically the power supply needs to supply according to the variation of the intermediate load. Okay, so next is load profile or load curve. Okay, so load curve or load profile is actually a graphic record showing the power demand for every instant during a certain time interval. So basically this is the load profile or load curve. So basically it has the record of the demand, okay, at a certain interval. Okay, so such a record may cover, can be 1 hour or 24 hour, a month. Okay, so monthly load profile or a year. Okay, 8760 hour. So depend on the interval. Okay, so load profile for load curve also. Following point are the worth noting. The area under the load curve represent the energy generated in the period considered. Okay, what is this mean? That you can see here, for example, this is power. Okay, so let me. Okay, this is power. So if you look at this area, okay, this is actually energy. So remember, P energy is equals to power multiplied by time. Or if you look at the area under the curve, E is equals to integrated from 0 to time power, you get PT. So area under graph. Remember integration. Okay, when you integrate the equation here, is basically the area under graph. Okay, look at the second point. The area under the curve is divided by the total number of hours given the average of the power system. Okay, so for example here the time is maybe for this case 24. Okay, 24 hour. Okay, so you have power here. Okay, and then the energy maybe 30 kilowatt hour. Okay, so the energy is, when you integrate this, you get 30 kilowatt hour. So if you divide by 24 hour, you get the average. Okay, so 30 divided by 24 is around 1 point something. Okay, kilowatt hour per hour. Okay, this is the average. Okay, this is mean by number 2. Okay, the peak load demand per the peak load indicate by the load curve represent the maximum demand of the power. This one. Okay, I already explained this. Okay, and the base load is the lowest demand registered. So you can see here, you look at the lowest point. Okay, maybe this graph is not good. Okay, maybe I draw another load profile. Okay, so something like this. Okay, so this is the base load. Okay, you can see here, this is the lowest demand, so this is the base load. Okay, this is another example. You can see here, this is the lowest demand, okay, at 23 May 2000. Okay, this one is the lowest. This is the highest, the peak demand. This is the average demand. Okay, so I think that's it for the load profile. Okay, you need to know the point. Okay, the load profile can be hourly, daily, monthly, annually. This one I already explained. Depend on the nature analysis carried out by the level of precision required. Okay, so of course you need to know how to determine the base, the peak, the average. Okay, so this is another load profile example. Okay, you can see here microwave, washing machine, iron. Okay, the largest one is the shower. Okay, the heater of the shower is quite large. I think it's around 3000 watt. Okay, and what else? Refrigerator. Okay, it's just a small one. Okay, okay, another one. Okay, aircon, of course, air conditioner is quite high. Okay, this is another example of load profile in hourly. Okay, so you can see here, this is building A. You have the building total. The square is the total. This one is the subcategory of the load. Okay, next is the significance of the load curve or load profile. Okay, the significance is give the information about the incoming load and help to decide the installed capacity of the power station and to decide the economic size for various generation unit. So when you have the load profile here, so it is easier to design the power station. Okay, you have a power station here, something like this. Okay, then you have a load. So the load has the, for example, peak 20 kilowatt. Okay, 20 kilowatt, and you have base 20 kilowatt. Okay, maybe you have two power supply here. Okay, two generation. So one is for the base. Okay, this one usually very hard to turn off. Okay, usually, for example, nuclear, you cannot easily turn off the nuclear. So this one become the base supply because it can supply this always on. Okay, this one always on. And then, for example, this one maybe you can use diesel generator, which respond very quickly. Okay, according to the load demand. So for example here, this is load demand. For example, this is 20, base is 10, so this one is 10. So always the base is 10 kilowatt. Okay, and this one quick response another 10 kilowatt. So something like that. Okay, so you have to design the generation system. Okay, the base is usually much cheaper. Okay, we use a cheaper generation, and this one usually very high not economic. Okay, that's why the load profile is very important. Okay, because we want to design something like this. Okay, for example, this one, okay, we divide it. For example, this one is only small time, this one usually quick, okay, and but expensive. Okay, and for this one usually in the middle. Okay, it's not very quick but it still can supply the system, and it's not too expensive, not too cheap. Okay, something like that. That is mean by sizing. Okay, okay, incoming help to decide installed capacity of the power station. Okay, make sure you know the installed capacity means that the capability. Okay, for example, if I said 50 megawatt thermal station. Okay, this means that the thermal station, okay, thermoelectric station has the 50 megawatt capability. Okay, for example, 100 megawatt, okay, hydro station. Okay, means that the capability of the hydro station is 100 megawatt. Okay, it's also help to estimate the generating cost and to decide the operating schedule of the power station. Okay, the sequence with the different unit to be run. Okay, this is what I meant. Okay, usually they have to divide. Okay, if you have a load profile, it is help you to make sure that who operate at what time and what operate at what time. Okay, so you can schedule the operation. Okay, and make it much more economic. Okay, so make sure you understand why the load profile, load curve is important. Okay, as I also mentioned that remember that I said the load, if the load wants 1000 megawatt, the supply needs to supply 100 megawatt also. Okay, remember P in is equals to P out. Okay, so that's why we have to meet the load demand. Okay, it cannot be more, it cannot be less. Okay, the supply needs to balance with the demand. Okay, okay, represents arrangement of all element of load, chronicle the load curve in order to descend magnitude. Okay, so you can see here a type of load profile, something like this. Okay, at the morning you have 18. Okay, in the early morning, okay, in the morning you have 35, and then in the afternoon, okay, you have 24, and so on. Okay, typical daily load curve. So this one is daily. Okay, because it is show on one day usage. It may be observed that the maximum load on the power station is 35 here. So maximum power is this. So you can represent this in the descending magnitude. So what you have to do is just sort this load. Okay, it will go something like this. Okay, you can see here, this is the load. Okay, 35 is the highest, you can see here, and then 30 and 24. Okay, 35, 30, 24, 18, and then 3. Okay, 18, 3. So you sort it according to the descending order, and then you look at the time. Okay, you look at the time, you find the duration. So you can see here, this is 2 hour, this is 6 hour, this is 1 hour, this is 3 hour, this is 12 hour. Okay, so if you rearrange everything, you get something like this. Okay, you can see here, this is 3. Okay, this one is 12 hour. Okay, you have you see this is 24, this is 6 hour, and then this is 3 hour. So 3 to 6 is 3 hour, and then 24 kilowatt is only 1 hour. So something like this. Okay, okay, and lastly is 12 hour, 12 to 24. So what is this called? Is called a load duration curve. So this is the load profile, okay, or load profile or load curve, and this one is the load duration curve. it is based on duration and not time. This is based on the time, this is based on duration. Okay, so make sure you know how to convert it and what is the difference. Okay, what is the point of making the load duration curve? Okay, the area under the load duration curve represent the total energy delivered by the generation station. So this one also the same. So area here is the energy, okay, because this is power. You can see here kilowatt is power. So the area here is the energy, and the load duration curve give a clear analysis of the generating power economically. So you can schedule which power to use for 3 kilowatt, which power to use for 18 kilowatt, and so on. So you have to make sure that the longest, okay, this one should be cheap, okay, because it is a long time. So this one needs to be cheap. Okay, this one might be very expensive because it is short time. Okay, so let us look first. Okay, so proper selection of base power plant and peak power plant become easier. So this one I already mentioned how to select the base power plant, which is turn on continuously, and okay, another one is the peak power. Okay, peak power plant. So peak power plant only, okay, satisfy the demand at the top. Okay, so make sure you understand why this load duration curve is plotted. Okay, before I forget, make sure you slide in your attendance. Okay, your attendance in the e-learning. Okay. Okay, next we move on to the next part, which is load factor. Okay, what is load factor? The load factor is the ratio of average power to the maximum load demand. So basically you find the ratio average divided by the maximum demand. Okay, load factor should be high. If it is unity, the plant use or being used over all period of time. Okay, so this one should be high. Okay, it varies with the type of load being poured for lightning and high for industry load demand. Okay, so what it means by all of these word? Okay, let me describe it in the form of equation. Okay, so as I show here, so for example your load look like this. Okay, so this is peak. Okay, and this one is average. Okay, so load factor is equals to, remember average is the total energy divided by interval. Okay, remember that I said find the area here. Okay, this is P, find the area and then divide by this one, the average. Okay, so load factor is basically average divided by P. Okay, we want the better one is 1 unity. Okay, and lower is bad. Okay, how? Okay, how to understand this? Okay, for example, as I mentioned here, the load factor that is poor is lighting. Okay, so why the lighting is quite poor? Okay, so remember lighting, for example this is 6 AM, so this 6 PM. So lighting is basically something like this. Okay, and something like this. So this is during the day. This is night. This is night. For example, this is 20 kilowatt. Okay, so this one around, okay, and then the average is maybe 5 kilowatt. Okay, for example, I am not sure. Okay, if want to, okay, actually 10, because it's half. Okay, 10 kilowatt. So this is the average. So load factor is equals to 10 kilowatt divided by 20 kilowatt. So load factor is 0.5. So this one is poor. Okay, it's not very good. Okay, how about it said that industrial load, okay, is high. Okay, so in industry, you can see here in industry, okay, you have this is time, this is power. Usually industry doesn't turn off the machine. Okay, so it always on. Okay, it's always consistent. For example, this is 20 kilowatt. Okay, and the peak is also 20 kilowatt, average and peak. So what is mean that the load factor is equals to 20 divided by 20 kilowatt. Okay, load factor doesn't have any unit. So 1 unity. Okay, when it is 1 is unity, it is good. Okay, so you can see here why the industrial load is much more higher. Okay, it has better load factor. Okay, we want a good load factor because you can see here in lightning. Okay, the load doesn't turn on. So when the load doesn't turn on, you have to make sure you install 20 kilowatt capacity. Okay, so you can see here you need to have 20 kilowatt capacity. Okay, but it is not turned on 24 hour, only 12 hour. Okay, so this is just a waste. Okay, so the energy cost, for example, for this one is $1. Okay, 1 ringgit. This is just example, 1 ringgit. But because it doesn't use for 24 hours, it will become 2 ringgit. Okay, just to cover the cost. But because of if you use like this, okay, you can see here it always on. Okay, always on. Okay, so for example, cost of installing this one is 20 kilowatt. It's also need 20 kilowatt, but the cost is only 1 Rm1 because it use all the time, so it is much more cheaper. Okay, so that's why we look at the power load factor because of the of this economic factor. Okay, this one I already explained to you. Load factor is the average divided by maximum demand. Okay, daily load factor, this one is for 24 hours. Okay, kilowatt hour, this one use energy. Okay, you can use power or you can use energy, but for this case I suggest you use energy. Okay, and okay, I forget to multiply. So make sure you multiply it. Okay, for this one is power, no need to worry. Okay, but for energy you have to multiply by 24 because you can see here this is the energy. Okay, energy is based on 24 hours. Okay, energy generated in 24 hours. So this is the maximum demand in kilowatt. Okay, so make sure you be careful with this one. So if you use energy, okay, this one is power, make sure you multiply by 24 or divide by 24 because you have to convert kilowatt hour to watt hour again. Okay, maybe I should give you a better example here. Okay, this is time. Okay, this is energy. Okay, so you have 10, you have 20. Okay, you have 10 again. Okay, so this is, so you have 8, you have another 8. Okay, this one maybe no need, easier to calculate. Okay, maybe this is your load profile. This is from 0 to 12 and then 12 to 23. Okay, so you have 24. Okay, so you have 24 hour. Okay, so you can see here the average is, okay, the average is, okay, maybe this one is power. Okay, not energy. So this one is 10 multiplied by 12. Okay, so 10 kilowatt maybe. Okay, kilowatt multiplied by 12 hour plus another 12 hour here, 20, okay, multiplied by 12 hour kilowatt. Okay, so the answer is 360. Okay, 360 kilowatt hour. Okay, so this one is the energy generated. Okay, and the maximum demand is 20. Okay, 20 kilowatt. So according to this formula daily, okay, remember this is the total energy. Okay, but if you want to use average, you have to divide by 24. So basically, okay, the average is 360 kilowatt hour divided by 24. Okay, because you want to find the average, and then the maximum demand is 20. Okay, you have to calculate something like this. So 360 divided by 24 multiplied by divided by 20. So you get 0.75. Okay, so be careful. So this one is the energy generated, not the average energy. Okay, so this one will become the average energy. Okay, so another example here, load factor kilowatt hour in 24. Okay, so you can see here Lmax multiplied by 24 hours divide by Lmax also. Okay, 24. So you get 1. Okay, the load factor is 1. So basically this one is good load factor. So how about this one, case number 2? So you can see here this is the Lmax, maximum load demand. Okay, so the average is, okay, you can see here L multiplied by 6. Okay, so L, okay, L is the kilowatt hour energy for 6 hours. Okay, you have L is multiplied by 6. Okay, the power multiplied by 6, you get the energy, all of this energy. Okay, and then plus 0 multiplied by 18. So this is an empty space, so 0. So divide by, of course, this is the energy. Okay, you have to divide by the you have to use the average. Okay, the average, so you have to divide by 24, and then you have to divide by the highest value. Okay, maximum demand. So you get 0.25, which is very bad. Okay, so that's it for load factor. Okay, we continue with the diversity factor. Okay, diversity factor defined as the sum of individual. Sorry, I have to check the recording first. Okay, defined as the sum of individual maximum demand of a customer divided by the maximum load demand of the system. Okay, this factor measures the diversification of the load, and it is concerned with the installation of sufficient generation and transmission plan. Okay, so all of this factor is basically just to in the planning, okay, to make sure that the generation and the transmission is enough for the load. If all the demand occur simultaneously, the diversity factor would be unity. Okay, and many more generation would have to be installed. Okay, however, if the factor is usually higher, especially for domestic load. Okay, so this factor for domestic load is much more higher. Okay, and you need to know that if all demands occur simultaneously, the diversity factor will be unity. Okay, so how to calculate it? Okay, so higher diversity factor could be obtained if the customer could be persuaded to take load action as this case. So you can see here diversity factor, sum of individual, maximum load demand, okay, maximum load demand of the entire group. So you can see here, okay, so this is sum of the load demand, okay, all Lmax, okay, you have 4 Lmax, okay, divided by the Lmax of the entire, so you get 4. Okay, so basically this is just a balance. Okay, the load is turned on all the time. Okay, so how about case number 2? Okay, the diversity factor. Okay, you can see here, okay, L plus L plus L plus L divided by 4L. Okay, so you can see here the sum of individual maximum demand is all 4. Okay, 1 2 3 4 L divided by the maximum of the entire group, which is 4L, is just equals to 1. Okay, next is load sharing between base load and the peak load. Okay, as I mentioned before, okay, in examining the load curve, it is noted that the load of the power station system is seldom constant, it's not constant. Okay, you can consider the load into 3 parts. Okay, as I mentioned before, the base, the peak, and intermediate. Okay, maybe I should redraw this. Okay, for those who still not understand. Okay, for example, you have a load something like this. Okay, so this is the base, lowest one. This is the peak. So this is intermediate. Okay, so make sure you know which is which. Okay, so the base power plant, okay, deliver full power all the time. Okay, this one as I mentioned before, okay, you have to deliver all the time. So this is time, so you can see here, okay, the power is always on. Okay, so this one usually using nuclear or coal fired station. Okay, because this is well adapted to the base demand. Okay, it's hard to start, okay, because you know coal take times to burn, okay, to heat up, so it cannot be changes easily. Okay, but it is quite cheap, that's why it become the base, okay, base power plant. Okay, so this is main by base power plant. So if I draw this one is basically coal or nuclear. Okay, thermal power station using gas or coal takes 4 to 8 hours to start up, while nuclear station takes several days. This is what I'm saying. Okay, gas. Okay, this type of power station takes time to turn on. Okay, it cannot easily change. That's why this one become the base power plant. Okay, the economic characteristic of the base power plant should be supply at a high capital cost. Okay, supply power at high capital cost, low cost operation. Okay, capital cost means that at the beginning it costs very high, but the operation cost is low. Okay, and it has high load factor. Okay, high load factor means that it always turn on. Okay, let me remember this one, load factor. Okay, this one always turn on, high load factor. Okay, and it is very efficient, okay, because it runs all the time, so the system needs to be efficient. So that is the characteristic of the base power plant. How about intermediate power plant? So intermediate is basically this one, okay, in between. So in between, okay, the intermediate power plant, the station can respond relatively quickly to the change in demand, usually by adding or removing one or generation unit. So this one usually hydropower station, okay. You can just disconnect the generation, okay, and disconnect or connect the hydropower generation. So this one usually intermediate. Okay, how about the peak generation? So peak is much more different, okay. So peak, you can deliver power for a brief interval during the day. Okay, if you look here, this one, the peak is usually during the day, okay, because machine turn on and everything, load increase. At night, machine the load is quite low. So okay, for peaks, it must be quick, okay, put into service very quickly. Peak generation needs to be quick, okay. It's operates for a short time, and it must be very quick. They are equipped with prime movers such as diesel engine, gas turbine, compressed air motor, pump storage turbine that can be start up in a few minutes, okay. The peak load plant should be inexpensive in the starting and shutting down operation, okay. So this one usually quite cheap, okay, because it cannot operate all the day, so it needs to be, capital cost needs to be cheap, okay. If not, it's not economic. Okay, the economic characteristic should be they can supply power at low capital cost, although the high or operating cost, okay. This one I mentioned before, okay. To build it is quite cheap, but the operation is quite expensive, okay. So that is the characteristic of the peak, okay. So low capital but high operation, okay. For base is flip, you have high capital cost but low operation cost, okay. Intermediate is hard to characteristic, but base and peak you can see the relationship. Or maybe I should draw this to avoid confusion, okay. Okay, you have a base, intermediate, peak, okay. So intermediate is quite to categorize by this one, the fast, okay, capital, and then operation cost, okay. So fast, so for base slow, okay, it takes time, but for peak it is fast. Capital, okay, for capital cost it is quite large, but this one is small. Operation cost for peak is quite large, but this is small, okay. So the relationship is something like that. So intermediate is in between, okay, usually in between, okay. What else? Okay, the operation time. Okay, maybe I should, okay, let me do a proper table. Okay, so the start, okay, start is long, okay, start time is long, this one is short, this one is considered short also, okay. So operation duration, this one all time, okay. Okay, this one is short, this one intermediate, Okay, so capital cost is quite high, so this one depend. Okay, but usually high also, GH high. Okay, and this one is capital cost should be low. Okay, and operating cost, this one should be low. This one usually depend, but usually low also. Okay, this one also depend. This one is high. So make sure you know the difference between the generation station. So all of this is called load sharing. Load sharing between base and peak load. Okay. So let's look like at an example. A power station deliver the load here. Okay, 45. This one the time. Okay. Plot the load profile. I think I already give the answer. Okay. So maybe I should show you how to do it one by one. Okay, so plot the load profile. Of course you have to plot the load profile. You can see the time is 6:12. Okay, you have a different interval here, so you have 6, 12, 14, 18, and then 24. Okay, you have the maximum is 150, 150. Okay, this one is 100. Okay, this one is 50. Make sure try to sketch accordingly, not to be so. Okay, try to use a good range. Okay, so this is load. Okay, in megawatt. Okay, so for the first 6 hours is 45 around this time. Okay, and then this one is 135 around this location. Okay, and for this case it's only 90 around here, and then you have 150 here. Okay, and then you have 75 around here. Okay, so you answer the first question, which is load profile. Okay, something like this. So I suggest you put the number. Just put the number. It is much more better. This is sketching. So 45, 135, 90, 150, and 75. So next plot, you have to plot the load duration curve. Okay, so plot the load duration curve. So first of all, you have to, okay, the same thing, T. Okay, and this one is L and W time. This one is hour. Okay, make sure you put the unit. Okay, so you have again 150, 100, and 50. Okay, so the highest one is 150. So how long is it? 4 hours. So maybe around here. Okay, this is 4 hours. How about next? 135. So 135 for 6 hours. So 135 is around here, a bit long. So 6 hours is 10. Okay, so 6. Okay, this one is 6. 12 minus 6 is 6 hour duration. So 4 plus 10 is 4 plus 6 is 10. Okay, next is 90. 90 only for 2 hours, so only short one. So 2 hours, 10 plus 2 is 12. Okay, 90, 30. Okay, 75 for this one. You have 18 until 24 is 6. Okay, you have 12 plus 6 is 18, And lastly, the smallest one is 45 is here. Okay, 24. Okay, so you get 150, 135, 190, 75, and then 45. Okay, so this is the load duration curve. Make sure you know how to draw this. Okay, you can see here 4, 10, 12, 18, and 24. Okay, choose the suitable generation unit to supply the load. Okay, so this one you have to recall back the load sharing. Okay, the first generation unit is 45 megawatt. Okay, so how to select this? Okay, so from this, okay, you can see here 45. Okay, so this is the first unit. Wait, okay, so let me, where is the pen? So this is the first unit. So you have first unit 45 megawatt for 24 hour. Okay, this one is not responding very well. Okay, let me, okay, so let me try again. So you can see here the first unit you have 45 megawatt, okay, for 24 hour. Okay, the second unit here you need to supply 30 megawatt for 18 hour. Okay, this one. And the third unit is 15 megawatt. Okay, third unit is 15 megawatt for 2 hour. Okay, 2 hour. Okay, and this one, the fourth unit is 100. Okay, 135 minus 90, 135 minus 90. Okay, 135 minus 90 is 45 megawatt. Okay, for supply for 10 hour. And lastly, this unit you have to supply 150 minus 135, you get 15 megawatt, needs to supply for 4 hours. Okay, so let us check. Okay, the first generation unit 1 is 45 for 24 hour. Okay, so this one, okay, 45 minus 0 is 45, and then you look here 24. Okay, let me clear this up first. Okay, so let me, so 45 minus 0, okay, you get 45 megawatt for 24 hours. So that is the first unit. Okay, the second unit you can see here 75 minus 40. Okay, second generation is 45. Okay, 75 minus 45 should be 30. Okay, should be 30. Okay, y is 45. Okay, should be 30. Okay, I think something wrong with the answer. Okay, let me check first. Yeah, I think this one has problem. Okay, but it's okay. You should just look here. Okay, 45 minus 0 is 45 for 24 hours. Okay, 75 minus 45 is 30. Okay, 30 for 18 hours. Okay, you can see here this one. okay, and then 90 minus 75 is 15 for 2 hours, for 12 hours, and then 135 minus 90 is 45 kilowatt for 10 hours, okay, and lastly 150 minus 135 is 15 megawatt for 4 hours. That is how you, okay, schedule a, okay, schedule a generation. Okay, so make sure you know how to do this. Okay, I think the answer is something wrong with the answer. It's okay, just follow the set I have given. So basically the first generation is this one. Okay, the second generation should be cover this one, the third generation should cover this one, the fourth generation should cover this one, and the last one should cover this one. So you have 1, 2, 3, 4, 5. Okay, you should have 5 generation unit. Okay, it's okay. We proceed. Determine the maximum demand energy generated per day and the average load. Okay, average load and load factor. So maximum demand is 150. Okay, let us check the answer. So maximum demand is 150 megawatt. Okay, occur during 14 to 18 hours. So you answer the first question. Energy generated per day. So this one you just multiply with the duration. Okay, let me adjust this. Okay, so you just get the duration here. So 45 multiplied by 6 minus 0, and then plus 135. So this is energy per day. Okay, 435. Okay, 12 minus 6. Okay, the duration. Okay, plus, okay, 90, 14 minus 12. Okay, and then plus 150, 18 minus 14. Okay, and then plus 75 multiplied by 24 minus 18. So energy is equals to megawatt hour. So make sure the unit you multiply it. So let us look. So 45 multiplied by 6 plus 135. Okay, this one is wrong also. Make sure you be careful. 135. It should be 135. Okay, 135 multiplied by 6 plus 90 multiplied by 2 plus 150 multiplied by 4, and lastly 75 multiplied by 6. You get, okay, I'm not sure whether this is correct or not. Okay, so something like that. Okay, so next is the average load. Okay, so average, of course, you have to divide by the time. So you can see here this is 24 hours. So you, let me get the answer first. Okay, the answer is correct. 2310. Okay, only this one is wrong, so no need to worry. And then the average load, of course. So this one is average load is just take E. Sorry, average load is equals to E divided by 24. Okay, because it is 24 hours, so you get 96250 kilowatt. Okay, so the average load is this one. Then the load factor, of course, you just use the formula. Load factor is equals to this one, 96250 divided by the peak is 150. Okay, 100,000. Okay, so be careful. This one is mega, this is kilowatt. So depend on you. Usually we use kilowatt. Okay, so you get answer 0.68. Okay, it's not a very good load. Okay, good load should have 1. Okay, we have complete the example 1. So now we move on to tarif. I think that's it for today. Okay, we continue tarif in the next class. Okay, so see you again tomorrow. Make sure you slide in your attendance because you have to make sure your attendance is more than 80%. Okay, to attend final year exam. Okay, that's it. Make sure you finish up your assignment too. Okay, see you again.